Foundation Level Objective. 4.2.1 K3 Use equivalence partitioning to derive test cases. Welcome to Chapter 4, Questions, where I usually have heated arguments with my students about every question. So take a deep breath and get ready for a tough ride. Let us start with the equivalence partitioning. You will surely be asked this in the exam. Listen carefully to what I am going to say now. You need to pay extra attention when defining the partitions. The trick to solving equivalence partitioning questions is to understand that we should use one value only from each partition unless we have to. I will explain what I mean by unless we have to while solving the coming questions. If there's an answer option that uses more than one value from the same partition for no good reason, then this is for sure a wrong answer. Let's start with first question. You are testing a simplified apartment search form, which has only two search criteria. Floor, with three possible options. Ground floor, first floor, second or higher floor. Garden type, with three possible options. No garden, small garden, large garden. Only apartments on the ground floor have gardens. The form has a built-in validation mechanism that will not allow you to use the search criteria which violate this rule. Each test has two input values, floor and garden type. You want to apply equivalence partitioning, EP, to cover each floor and each garden type in your tests. What is the minimal number of test cases to achieve 100% EP coverage? First, we need to define the partitions. We have two variables, floor and garden type. Do the values under each variable behave the same? The answer is no. An apartment on the ground floor, first floor, second or higher floor may not look the same. Same thing for the garden type. An apartment with no garden will not look the same as one with a small garden or a large garden. So, each value is a partition by itself. So we have 6 partitions: ground floor, first floor, second floor, no garden, small garden, and large garden. A single test case should hold a value from floor and a value from garden type. According to the scenario, second and high floors can't have gardens. Our first two test cases are 1 first floor no garden and 2 higher floor no garden. So far I have used 3 partitions, first, second floor and no garden. This is a situation where I have to use a value from a partition, no garden, more than once. We have 3 more partitions to use. So the remaining test cases are 3 ground floor small garden and 4 ground floor large garden. Here again I had to use ground floor more than once. So the total minimum number of test cases is B4. Many get confused and consider a 5th test case, ground floor and no garden. But again I have used no garden already and there's no need to use it again. Second question. Customers of the test. Wash car, wash chain have cards with a record of the number of washes they have bought so far. The initial value is 0. After entering the car wash, the system increases the number on the card by 1. This value represents the number of the current wash. Based on this number, the system decides what discount the customer is entitled to. For every 10th wash, the system gives a 10% discount. And for every 20th wash, the system gives a further 40% discount, i.e., a 50% discount in total. Which of the following sets of input data, understood as the numbers of the current wash, achieves the highest equivalence partition coverage? To define the partitions, we know that each value in a single partition should have the same effect on the system. In this scenario, the effect is the discount to which the customer is entitled. The car wash can provide 0 discount, 10% discount, or 50% discount. 3 partitions total. Notice that they say for every 10th and for every 20th. 50% discount for wash number 20, 40, 60. This is a partition. We will call this partition 1. 10% discount for wash number 10, 30, 50. This is a partition. We will call this partition 2. Any other wash number will get a 0% discount, and we will call this partition 3. We want the highest coverage, so covering 3 partitions is ideal. A, 19. Partition 3, 20. Partition 1, 30. Partition 2. 3 partitions out of 3. This must be a correct number. B, 11. Partition 3, 12. Partition 3. 20. Partition 1. 2 partitions out of 3. C, 1. Partition 3, 10. Partition 1, 50. Partition 2. 2 partitions out of 3. D, 10. Partition 2, 29. Partition 3, 30. Partition 2, 31. Partition 3. 2 partitions out of 3. The correct answer is A. Third question. You are testing a pin validator which accepts valid pins and rejects invalid pins. A pin is a sequence of digits. A pin is valid if it consists of 4 digits, at least 2 of which are different. You have identified the following valid equivalence partitions: variable, pin, code length. The partition length correct. 4-digit pins. The partition length incorrect. Pins with length other than 4. Variable, number of different digits. The partition number of different digits correct. Pins with at least 2 different digits. The partition number of different digits incorrect. Pins with all digits being the same. Which of the following is a minimum set of input test data that covers all identified equivalence partitions? This question saved us some time and defined the partitions for us. We have 4 partitions. I will check every partition and see if it's represented in the answer. If any partition is not represented, we will not continue with this answer option. A, 1, 2, 3, 4, 1, 2, 3, 4, 5, 1. The partition, length correct, 1, 2, 3, 4. The partition, length incorrect, 1, 2, 3, 4, 5. The partition, number of different digits correct, 1, 2, 3, 4. The partition, number of different digits incorrect, 1. It's 1 digit only, so we have no variations. So option A covers the 4 partitions using 3 values. B, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 2. The partition length correct 11, 11. The partition length incorrect 11. The partition number of different digits correct 11, 12, at least 2 different digits, 1 and 2. The partition number of different digits incorrect 1, 1, 1, 1. C, 1, 1, 2, 3, 4. The partition length correct 1, 2, 3, 4. The partition length incorrect 1. The partition number of different digits correct 1, 2, 3, 4. The partition number of different digits incorrect 1. So option C also covers all 4 partitions with 2 values only. C is the correct answer. D, 12,345, 1234. The partition length correct 1234. The partition length incorrect 12,345. The partition number of different digits correct 1234. The partition number of different digits incorrect doesn't exist. Option D is not the correct answer. So the correct answer is C, which is the same answer as the modal answer from ISTQB. Saying that, I have a problem with this question. I believe that we can create test cases by sharing valid partitions. So 1, 2, 3, 4 is okay with me as both length correct and number of different digits correct. But when I say that 1 is both length incorrect and number of different digits incorrect, is practically not a correct test case. Creating a test case by sharing invalid partitions is not a good practice at all. Well, imagine in that case, testing the software with the input 1 and a message appears saying wrong input. Did you know if it failed because of length incorrect or number of different digits incorrect? No, you will never know. That's why it's a best practice to create a test case for each invalid partition. Maybe this is an advanced topic, but at least you can use it in your day-to-day work or in an interview. So my point is, you can create test cases by sharing valid partitions, but create a new test case for each invalid partition. Fourth question. The system for selling cinema tickets calculates the discount type based on the client's birth year BY and on the current year CY as follows. Let D be the difference between CY and BY. 1. If D less than 0, then print the error message. Birth year cannot be greater than current year. 2. If D is greater than or equals 0 and D is less than 18, then apply the student discount. 3. If D is greater than or equals 18 and D is less than 65, then apply no discount. 4. If D is greater than or equals 65, then apply the pensioner discount. Your test suite already contains 2 test cases. BY Chin 1990, CY Cho 2020, expected result, no discount. BY Kin 2030, CY Kin 2029. Expected result, print the error message. Which of the following test data sets should be added to achieve full valid equivalence partitioning coverage for the discount type? Select 2 options. I believe this one is the easiest so far. The partitions have already been given to us and I have marked each one from 1 to 4 in sequence. We need to calculate the difference, D, for the 2 test cases that we already have and then for each answer. Test case 1. D equals 2020 minus 1990 equals 30. This covers partition 3. Test case 2D equals 2029 minus 2030 equals -1. This covers partition 1. So we need to pick the 2 options that would cover partitions 2 and 4. A. D equals 2065 minus 2001 equals 64. Covers partition 3. B. D equals 1965 minus 1900 equals 65. Covers partition. 4th correct answer. C. D equals 1900 minus 1965 equals -65. Covers partition 1. D equals 2029 minus 2011 equals 18. Covers partition 3. ED equals 2000 minus 2000 equals 0. Covers partition 2. Correct answer. So the correct answers are B and E.